The nature of a magnetic field. A magnetic field is produced by the motion of an electric charge. Magnetism is very much related to electricity. Just as an electric charge is surrounded by an electric field, a moving electric charge is also surrounded by a magnetic field. Charges in motion have associated with them both an electric and a magnetic field. Anytime you have a charge moving, we call that a current, right? So whenever there's a current, there's a magnetic field going around it. And you can figure out the direction of the magnetic field, how it's working, using our first right-hand rule. And that right-hand rule is gripping a wire. If you grab on a wire and your thumb points in the direction that the current is going, then your fingers naturally are curling in the direction that the magnetic field is going. So if I have a wire going this way, my magnetic field is going into the chalkboard, or into the camera, or out of the camera and into my face. Electrons in motion. Where is the motion of the electron charges in a common bar magnet? The magnet as a whole may be stationary, but it's composed of atoms whose electrons are in constant motion. So you always have these electrons swirling around the nucleus. The moving charge constitutes a tiny current, which then produces a magnetic field. Remember when I said atoms are basically just magnets? This is what's happening. More important, electrons can be thought of as spinning on their own axis like tops. A spinning electron creates another magnetic field. In most materials, the field due to spinning predominates over the field due to orbital motion. So because the field from the spinning is created, it's greater than the field that's coming up due to the orbital motion. So while it's revolving, it's also rotating, kind of like the Earth around the sun, right? It's doing one of these. But because the spinning, the rotating, the days are so much greater and happen more often, this matters more than the electron going around the nucleus. Every spinning electron is a tiny magnet. A pair of electrons spinning in the same direction makes up a stronger magnet. Electrons spinning in opposite directions work against each other. So if you have one going counterclockwise and one going clockwise, they're going to go against each other. Their magnetic fields will then cancel. Most substances are not magnets because the various fields cancel one another due to electrons spinning in opposite directions. Are you back? Did that noise make you check your phone? I'm sorry. Most substances are not magnets because the various fields cancel one another due to electrons spinning in opposite directions. In materials like iron, nickel, and cobalt, however, the fields do not cancel entirely. An iron atom has 4 electrons whose spin magnetism is not canceled. Every iron atom is then a tiny magnet. The same is true to a lesser degree about the atoms of nickel and cobalt. So we're starting to get to an understanding of how magnets work, which is really complicated, previously mysterious. But you have these electrons spinning, creates this magnetic field, and if there's a spinning in the opposite direction, then the magnetic fields cancel out. That's like most stuff on Earth, unless it can stick to a magnet. If it can stick to a magnet, then the spin magnetism is not canceled, and it still has some sort of magnetic field around it. And then when you bring a magnet in the presence of that magnetic field, it sticks together. Concept check. How is a magnetic field produced? Hopefully you can answer that by now.